Hey everyone, this is just going to be a short video introducing what parabolas are. This is going to be just conceptual, so don't worry so much about the math today. I'm just going to introduce it to you. That way tomorrow when we dive a little bit deeper into it, you'll have a better understanding about it. So, introduction to parabolas. What we got going on here is basically anytime you throw something in the air, it's going to cause projectile motion. So anytime you toss something, anytime you launch something with your catapult, that's going to create a projectile motion path. So when objects fly through the air, how many forces are acting on it? Well, probably just one. Gravity for sure is always acting on it. I mean, I guess if it had a rocket thruster, it could have another force acting on it. But if you have anything that's just free falling through the air or free flying, it's going to create a parabolic flight pattern because gravity is the only thing pulling it down. So as this ball gets launched across your screen, it gets launched with a certain velocity. You throw it with a certain amount of force. But after that, the only force that's going to be pulling it down is gravity. It's not going to slow down sideways, but it will slow down with how tall it's getting or how high it's going through the air. This is what we call projectile motion. And this parabolic flight pattern is what we call a parabola. So what is a parabola? In mathematics, a parabola is a plane curve, which is a mirror, symmetrical, and is approximately U-shaped. So that seems kind of wordy, but that's okay. Look at the pictures at the bottom of the screen. Those are parabolas. Sometimes they open downward, and sometimes they open upward. So a parabola is going to have an axis of symmetry, which means that in this one in the bottom left, this axis of symmetry just means that it is perfectly reflected on each side of that axis. So basically, it's going to make almost a perfect U. Is what we're going to be looking at here. Now, for our sake, we will not be using the ones that open upward. We're only going to use the ones that open downward because that reflects the path that our catapults will be making. So again, let's talk about some of these major important parts. For the sake of this class, we will only be concerned with parabolas that look like this, where they open downward. Now, the key pieces to this, and you can see it in the picture there, is the x-intercept is one of the most important parts. You can see the x-intercept is exactly what it sounds like. It's the point at where the line would cross the x-axis. Now, if we're launching a catapult, the x-intercept is just the place where we hit the ground. The ground is our x-axis when we launch things in the air. So when we have a parabola, we have two x-intercepts. We will always have two x-intercepts. The only exception to that is if your catapult doesn't launch specifically from ground level. We'll talk about that next week. But the reason I had you figure out your maximum distance of your catapult is because that is your x-intercept. For your y-intercept, it's exactly what it sounds like. It's the point at which it crosses that y-axis. Guess what? We don't care. Yeah, we don't care about a y-axis for this wonderful graph. We're skipping that. The next big thing we need to know, though, is the vertex. This is the highest point of your parabola, and it's also the midline of your parabola. It's your axis of symmetry where each side is perfectly mirrored thanks to that darn gravity. So the vertex is just the highest point at which you launched your catapult. So yesterday when I asked for you to figure out your maximum height and your maximum distance, what you were really finding was your vertex and your x-intercept. We'll talk more about that next week, but now you know what you're looking at. So why do we care? The catapults you built launch things in what we call projectile motion. The path of whatever you launch will always look like a parabola. So in this picture here, you can see the catapult and it's launching that object. Now it's not starting at the ground, so we're only going to see one x-intercept in this picture. And it's all the way to the right. It's when that ball hits the ground again. Boom, that's an x-intercept. We also can see a vertex, which is the highest point in this graph or in this parabola. Now, the really cool thing about finding these positions and finding this data is that if we can find that, we can calculate the path of trajectory or the projectile motion. That might not seem that cool, but this has been used for a really long time. So calculating these parabolas and this projectile motion, that's using a form of math called quadratics. We're going to talk about that way more tomorrow and actually on the next slide. But if you look at these pictures, back in the day, people have been using physics for thousands of years and the catapult isn't an exception. Projectile motion, which was used by the catapult, has been used for a really, really long time. What's that castle over there? Let's break it. Well, it's not always that simple. It may seem super easy, but back in medieval times when you were launching a catapult, you only had so many resources. So if you kept firing and missing your target, like in that top picture, you're going to run out of resources and you could lose the battle. So what they had to figure out was the math and science behind this catapult in order to save their time, in order to save their resources, and ultimately win any battle that they were trying to engage in. So as we build our own catapults, we will be able to figure out this flight pattern and we'll be able to hit our target successfully. So quadratics, what is Ms. Berg talking about? Well, a quadratic formula is where the highest exponent variable in an equation is squared. That again is super wordy, but if you look at the examples here, you can see this y equals x squared minus 3x plus 4. A quadratic formula just means that the highest exponent is going to be a square. It's going to be a 2. And it has to have a squared value on one of the exponents. So if this just said y equals negative 3x plus 4, it would not be quadratic because it wouldn't have a squared variable. Now in the second example, we have y equals 2x squared plus 16. You can see we're missing this middle variable where there's just one x. That's okay. A quadratic formula is anything where the variable is squared. And so we'll talk about this a lot more tomorrow. I'll teach you how to calculate it. Don't worry about that. The reason why we're talking about this is because this is what produces a parabola and what's going to allow us to calculate the trajectory of our catapults. Later this week, we're going to actually dive into that quadratics and math. Tomorrow, you'll get another tutorial about how to actually calculate quadratic formulas. This will be a review for some of you, and it'll be new to some of you. That's okay. Please don't panic. Don't look at this stuff and say, wow, that's impossible. My goal is that I'm going to be able to explain this and give you examples and help you to make this as easy as possible. So in the future, you'll be able to dive into that math a little more confidently, and also you'll be able to enjoy the project that we're doing. Next week, you're actually going to create a quadratic formula for your own catapult so that you can aim and hit any object within range. That's the dream. Hopefully you enjoy it. Have a fantastic day, everybody. Thank you for watching this video. Now that you've watched it, don't forget to answer the question in the top right-hand corner. If you feel really comfortable about quadratics, just say you feel good about them, you know what they are. If you have questions, you can answer them there too. If you've never learned about quadratics before, just type that in the box and don't worry, I'm here to help you. Reach out whenever you need to. Have a great day, everybody.